I will go over problems 8 and 9 in section 12.2 with you now. For problem number 8 on page 612, we will do the 8-step hypothesis test here. Step number 1 is to write the claim. And if you read through the problem, it says test the claim that the three size categories have the same mean city fuel consumption. So a way to write that algebraically is that mu1 equals mu2 equals mu3. Step 2 is the opposite, and the opposite of that is to just write out a sentence in words that the means are not all equal, at least one of the means is not equal to the others. That's what the opposite would be. Step 3, our null hypothesis will be the same as the claim. So we will have mu1 equals mu2 equals mu3. And for the alternate hypothesis, you can copy down the same wording you used for the opposite statement. Step number 4, alpha is given as 0.05. Step 5, in this section, we are using the F-test statistic, and I would suggest writing out the test as well, ANOVA. That stands for the analysis of the variance. So I would write that for step 5. Step number 6, we do not need to calculate anything. Look at the stat disk box. Critical value is given for F, so we have the F critical value is 3.55 4561. Right before that is the F test statistic is 23.9 45652, and P value is given in the far right column as 0.000008. Step 7, we compare the values in 4 and 6. So if we want to use the p-value test, we have that the p-value is less than alpha, which implies that we will reject the null hypothesis. Now we're also given the F test statistic and the critical value, which we don't have to do, but if we did do that, you would see that the F test statistic is greater than F critical value. And if you check your notes, you would find that also implies that you will reject HO. Whether you use the p-value method or the critical value method, you should get the same result. So then step 8, we just need to use the correct wording. So we have reject HO, and we have our original claim includes equality. That is wording number 3. And you would write something like, there is sufficient evidence to warrant rejection of the claim that the three size categories of cars have the same mean fuel consumption. So again, wording number 3. Problem 8 also says, does the size of a car appear to affect city fuel consumption? The answer would be yes. The size of the car does appear to affect city fuel consumption. We rejected the null. We rejected that they are all three equal. Therefore, there's evidence that perhaps they aren't all equal and that the size of the car would affect city fuel consumption. Okay, so then let's go to the next problem, number 9. We also have the table of data values, so we won't need our calculator. Step 1 is to determine the claim. Reading through the problem, we see it says to test the claim that the three size categories have the same mean head injuries. So we're working with cars again. So the claim would be that the three means are equal to each other, so mu1 equals mu2 equals mu3. Opposite is that these three values are not all equal to each other, that at least one does not equal the others. So it's most correct if you write that out rather than try to do it algebraically. Step 3, our null hypothesis, is our claim. So we will copy down the claim. And then the alternate hypothesis, we would use the same wording we did for opposite. Step number 4, we have alpha equals 0.05. Step 5, again, we're using the F test statistic, the ANOVA test. Step 6, looking at that chart, we have the F value. The F there, that's going to be understood that that's the F test statistic is 0.161. Now on the far right where it says SIG, that would be the significance value. When you think of alpha, that's our significance value. So what that is actually is our p-value. The p-value in this case is 0.852. Step 7, we will compare. We have that the p-value is greater than alpha. Now in this case, I'm finished there. I don't need to calculate my critical value unless I'm asked to. And that gets a little more complicated when it's not given, because if you look at the chart in the back of the book where you have your F tables, it's not always as easy to determine. Let me find what page it's on. Table A5, page 731 and 730, that has if the alpha is 0.05. And just by looking at those values, I have a test statistic of 0.61. Now I need to find my degrees of freedom in the numerator and for the denominator. And there's a formula in this section where I have k minus 1 divided by k times n minus 1. And I think he included this in your notes as well for this chapter. And k is, I believe in this case, you would have k equals 3 and then n equals 7. Because for each of these, you have to look at you have to look at the chart for this one. For page 9, you need to look at the data set they actually used, data set 13. Look at the back of the book, and there's mid-size and small and large. And each of those three groups have 7 cars, and that's how I get this. But I'm not even going to do that part because I have the p-value, and I can do the p-value test. So you may want to ask him, is this something you're going to have to know for the exam or not? That gets kind of complicated when you have to calculate the degrees of freedom and find the value, the F critical value off that table. So I have enough to test this, my claim, because my p-value is greater than alpha, and so I know that that implies that I will fail to reject my null. And then when I fail to reject, and my original claim is equality, that will use the wording for the number 4. And the wording for that is that there is not sufficient evidence to warrant rejection of the claim that the 3 size categories of cars have the same mean head injury measurement. So then when it asks, does the size of the car appear to affect head injuries, I will say no. The size of the car does not appear to affect head injuries. I failed to reject the equality statement. So there's a possibility that they are all equal, and therefore the size of the car does not matter. Okay. So I will post in a different video problems 10, 14, and 16.